So when I say a three-variable system, I'm talking about something like something that looks like this. So to this point, we had talked about three methods to solve a system of equations. The first method was graphing. Now, if I go to try to graph one of these equations that's in three variables, what kind of shape is my graph going to be? It's going to be a plane. So if I graph in one variable, you get a point. If you graph in two variables, you get a line. If you graph in three variables, you get a plane, basically. So graphically, I'd be looking for the intersection of three planes, which is like not that easy to kind of conceive about what that would even look like graphically. And graphing a three-dimensional shape is often quite difficult. We're not even going to attempt to talk any more about graphing of a three-variable system than what we've just done there. So it's not really an effective method for us because logistically of drawing these things on a sheet of paper is rather difficult. And even graphing a plane, that's like at some angle in three-dimensional space and getting that on a sheet of paper is really kind of a difficult proposition to get a decent picture out of it. So graphing is really not going to be a very good option for us. Substitution was the next method we had talked about. The problem with substitution in a three-variable system is things get worse before they get better, and the size of the equations kind of gets pretty long before things start kind of like combining together and nice things happening. And I think just from a bookkeeping standpoint of like keeping everything straight, it again is a difficult method just because you have so many things to kind of keep track of. Elimination is the method that we're going to prefer to use here. And the reason we're going to do that is because each time we do an elimination, things get a little bit smaller and a little bit simpler. And that's a great attribute to have, considering now we have more equations and more variables. So, see, I'm going to outline this process because it's a little bit longer than it was for a two-variable system. So I'm going to start with three variables and three equations. I'm going to do, yes, sure. We're then going to do two eliminations, and those two eliminations are going to result in giving us a two-variable system with two equations, which is just like what we saw in the homework yesterday. So from there, we'll do one elimination, which will give us a one variable and one equation, and that we can solve to get the first part of our solution. Once we have that first part of our solution, we're going to substitute back into one of these two variable problems and then solve to get the second part of our solution. And then once we have that second part of our solution, we're going to substitute both of those into one of the three variable equations and solve to get the third part of our solution. So before we started actually doing an example, I wanted to kind of diagram what the process is that we're going to be using and how it kind of works. Oftentimes having like a visual description of what you're about to do, especially if the process is a little lengthy, can be really valuable. So when we do this first example, I'm going to go back and refer to this flow chart here that I've created, just to kind of get you an idea of what we're doing and where we're doing it and why we're doing whatever it is that, during the process. Is everybody okay with that idea? And again, on a process like this, it's easy to kind of get what I want to say, lost maybe, because the procedure is a little bit long. So it's nice to have like a map of like, oh, here's where I'm at. This is where I need to get to. What I still need to do. That's probably kind of helpful, right? Okay. So let's actually go and try to do this now for this equation. So just like before, I'm going to label my equations with letters. I'm going to call them A, B, and C. And what I want to do is I want to first select a variable to eliminate. The best case scenario for me is if I have a variable whose leading coefficient is 1 or -1, that would be the ideal situation. If I look, I have a situation like that with the y's. So my first choice would be to eliminate the y's. If, for instance, you have a problem where there is no variable whose leading coefficient is 1, the next thing I would look for is a situation here like the x's, where all of the x's are divisible by, in this case, one of the coefficients 2. That would be the next best situation. If that doesn't happen, then it doesn't really matter which variable you choose to eliminate next, or eliminate first. Is everybody okay with that explanation? Do you have to do it this way? No. Does it make life a little bit easier if you choose to do it this way? Yes. So that's the only reason we're going to do that, or use that kind of a decision-making process, is because it makes the process a little bit easier. Okay. So we're going to eliminate the y's first. And I'm going to use equation C, the equation where my y has a coefficient of -1, as my eliminator equation. Basically what I'm going to do is I'm going to use equation C to eliminate the y's from equation A, and then I'm going to use equation C to eliminate the y's from equation B. So, what do I need to multiply equation C by so that when I add it to equation A, the y's will eliminate? 2. Can everybody see that? So I'm going to do 2C plus equation A. What What do I have to multiply equation C by? So that when I add it to equation B, the y's will eliminate. Close. -3. Everybody see that? Okay. So now I'm going to go ahead and write down my updated situation here. So when I multiply 2 by C, I get this. And then equation A, I'm just going to copy down. When I add down, I get 16x. The y's cancel out. Plus 11z equals -1. Then I'm going to do -3 times equation C. And then I'll just copy down equation B. Those cancel out. Is everybody okay with what we've done there? I'm going to refer to this guy as equation D, and this guy's equation E. And if I take those two equations together, that's going to form a new system of equations. Notice this system has only 2 variables and 2 equations. It's simpler than what we started with. I'm going to take a time out here and talk a little bit about some important observations or clarify a couple of points here. So we'll come back to this process. I just want to clarify a couple of things that are important here on this first step that we've done. So if we go back and refer to the flow chart, we started with this situation. We did 2 eliminations, and now we're at this situation. Everybody's okay with that? The important piece that I want to clarify is during this step, we eliminated the same variable each time. So I eliminated the y's when I did this, and I also eliminated y's when I do that. You must eliminate the same variable in each of these 2 eliminations on the first step. It will not work if you eliminate x's with one and then y's with the other. That is not good. That's not going to be helpful. Have to do the same variable. Is everybody okay with that idea? So let's continue now. Looking at equations D and E, which variable would we like to eliminate next? The x's. Hopefully that's obvious. You notice that they're already set to eliminate. All we need to do is add the 2 equations together. This is really kind of the best possible case for us. So the x's cancel out. 11z plus -7z is positive 4z. And then -1 plus -11 is -12. So if we go back to our flow chart, we did another elimination, and now we have a 1 variable in 1 equation. We can solve that equation just by dividing both sides by 4 to get that z is equal to -3. If we go back and look at the flow chart then, we've just done the solving, and we got our first solution. With that first part of our solution, we're going to go back and plug that answer into one of the 2 variable equations. It doesn't matter which one. So if I go back here, I'm going to plug z into either equation D or equation E. I'm going to plug it into equation D, just for the sake of picking one. So 11 times -3 is -33. When I add 33 to both sides, I get 16x is equal to 32. And when I divide by 2, I get x equals 2. So if I go back to my flow chart, what I just did was the solving step, and we got our second solution. The last thing I need to do now is to plug both my first and second solutions back into a 3-variable equation and solve for that remaining third variable. So I already know an answer for y and an answer for z. I just need to find my answer for x. So I'm going to plug those into, say, the first equation. Doesn't really matter. My answer for y was 1. My answer for... No, we don't have... I'm so stupid. We have answers for x and z. Right? Goodness gracious. Okay. So, my answer for x was 2. My answer for z was -3. And I'm now going to solve for y. So when I add 1 to both sides, I get 2y is equal to 2. And when I divide both sides by 2, I get 1. So my final answer then is 2, 1, -3. Is everybody okay with what we did there? Let's do another. So let's say we want to solve this system. these equations A, B, and C. So the first thing we want to do is choose a variable to eliminate. Is there really a bad choice here? There's not really a bad choice, right? Because the x's have an x that has a coefficient of 1. The y's have a variable with a coefficient of 1. And the z's have a variable with a coefficient of 1, right? So really there's not a bad choice, but there is one that makes life a little bit easier than the others. What variable would be the easiest one to eliminate first? I would do the z's. Which of the equations would I use as my eliminator equation? I would use equation B. Why would I use equation B? Because it's negative z and the other two are positive z. So to eliminate the z's from equation A, I just need to add it to equation B. And to eliminate the z's from equation C, I just need to add it to equation B. So I don't have to do any multiplication. That's why this one was the easiest route. Now, would have the other ways worked? Sure. Would they have been that hard? No. But is this easier? Yeah. And I'm going to always take the easiest route when I see it, right? Oh, a good mathematician is a lazy mathematician. You want to do it the easiest way possible. Okay. So, if I add equations A and B, I'm not going to recopy them because I didn't multiply anything. I have everything written up there. I can just add them together. X plus X is 2X. Y plus Y is 2Y. Z plus negative Z cancels out and gives me 0. And then 4 plus 4 is 8. If I add B and C, X plus 3X is 4X. Y plus 3Y is 4Y. Negative Z plus Z is 0. And then 4 plus 12 is 16. These guys are going to combine together to form my new system of equations. That was so fast. Which variable would you like to eliminate now? Does it really matter? No. So let's just pick one. Which one do you want to pick? X. Great. So what do we need to multiply one of these equations by so that when I add them together, the x's are going to cancel? Negative 2. Which equation do I have to multiply that to? D. Everybody agree with that? So when I multiply D by negative 2, I get that. And then I'll just recopy equation E underneath. Uh-oh. What do you notice is going to happen when we add these together? We get 0 equals 0, right? What did that mean again? Says we have infinitely many solutions. But we had talked about this, and we had said that infinitely many solutions, that description by itself is not going to be sufficient for us. We'd like also a description of how to find those infinitely many solutions. When we say infinitely many solutions, that doesn't mean like you can pick any values for x, y, and z, and this works. There's still some x, y, z's that work and some that don't. Now there's infinitely many that work, but there's also infinitely many that don't. We'd like a good description of kind of the ones that do work. So the way that we're going to get that is we're going to go back to our two-variable system. We're going to pick one of the two equations. I'm going to just pick equation D. And I'm going to isolate one of the two variables, either x or y. It doesn't matter which one we get by itself. For the sake of argument, I'm going to get the y by itself. So to do that, I'm going to subtract 2x from both sides, and then divide both sides by 2. And this is going to be 2 of the 3 spots in my solution set. So in the y spot, what I'm going to write is negative x plus 4, because that's what y is equal to. Is everybody okay there? Because this equation is in terms of x. X is like the independent variable. So in the x spot, I'm just going to write x. And now what I'm going to do is I'm going to take this and use it to plug into A, B, or C, and then get the z by itself. So I'm going to do this for equation 1, or A. I'm going to pick equation A, which is x plus y, but in place of the y, I'm going to write that negative x plus 4. Then I have plus z is equal to 4. So when I combine like terms, x plus negative x cancel out. And when I subtract 4 from both sides, I get z is equal to 0. So in that spot, I'm just going to, the z spot of my answer, I'm just going to write 0. So my final answer here is x comma negative 4x, or negative x plus 4, comma 0. So basically what we're going to be able to do is you can pick any value you want for x. Say we say x is 1. What that tells me then, y would be 1, or negative 1 plus 4, or 3, and z always would be 0. So one solution of my infinitely many is the tuple 1, 3, 0. And because we have infinitely many choices that we can pick for x, we're going to get infinitely many tuples, right? Everybody okay with what we mean by infinitely many solutions? That it's different from like all real numbers as a solution? That is not what we're saying here. There's a very specific set of values or set of solutions that actually work, and everything else doesn't, and there just happens to be infinitely many of both of them, which seems kind of counterintuitive, but that's the way that works. What do you guys think? So far, so good? I'm going to write up another system here, and what I'd like for you guys to do right now, just in your notebooks would be fine, I'd like you to try to solve this system on your own right now, and then we'll go through the answer here in a moment. in fact, I'll write the answer here ahead of time. So as you're working, if you get the wrong value for the first solution, you already know to go back and go look for a mistake rather than continue to barrel down that rabbit hole, and end up with 3 wrong answers. You know what I mean, guys? So let's take 10 minutes or so and work through this.